Okay, so right now we're going to take a look at multiplying fractions and mixed numbers. Now, I shared this example with us in class, and I think it's important for us to see what happens when we all actually multiply fractions. So I'm going to draw a picture, a model of 1/3, and I'm just going to draw a rectangle, no particular length, but I'm going to divide it into thirds. Okay, and I'm going to shade in 1/3. So this is my representation of 1/3. And I'm going to create the exact same fraction, the exact same piece, the same size model, but this time, instead of thirds, let's see, I used 6 boxes. Okay. 1, 2, 3, 4, 5. Let me get the same size. I'm going to divide it into fourths. And I would like to multiply these together. Well, I used the example that it would be like, oh, wait, I got to shade in 1/4. Sorry about that. 1/4. Okay. I used the example that it would be like if you had a birthday cake and you cut the cake into thirds, but you realize that you only have 3 pieces. And if we eat 1/3 of that cake, we still have 2/3 left, but this is an awfully big piece. If we cut our cake into vertical slices and we have 1/4 of our cake eaten and we have 3 slices left, you can cut your shape vertically and horizontally, either way. So what we're doing when we're multiplying is we're actually creating that same size cake. So I'm going to make the same size rectangle. And we're actually combining, we're actually slicing our cake horizontally. Here's our 1/3. We're actually multiplying 1/3 times 1/4. And I'm going to make my 1/4. Okay. And here's my 1/4. I'm shading exactly the way I shaded it here. I'm multiplying 1/3 times 1/4. And the spot where they overlap is our answer right here. So what we've done is we've created a new fraction that's out of 12s. So we had our thirds, we had our fourths, we overlapped them. We now see that we have 12 pieces, and altogether 1 is shaded in. That's where they both overlap. So this is a good visual representation of using an array to show how to multiply fractions. I'm starting with 1/3. I multiply that by 1/4. I'm creating smaller pieces. I'm actually subdividing my cake from thirds to fourths. Now I have 12ths, and 1 is shaded in. Now, a lot of times kids figure out and they go, oh, well, Miss Breen, all I have to do is multiply 1/3 times 1/4. 1 times 1 is 1. 3 times 4 is 12. I multiply the numerators by the numerator, the denominator by the denominator, and I have the answer. Yes, it's that simple. But the visual is really good to help you understand why that works. You don't need to do common denominators. We only do common denominators when we're adding, so we don't have to worry about that. We're just looking at the fraction as 1/3, and we're kind of overlapping it. We're creating an array, subdividing it into smaller parts. Okay, so it's pretty basic. So if I had the fraction 2/5 and I want to multiply that by 1/3, I would have 2 times 1, which is 2, 5 times 3, which is 15. Now, the biggest thing is simplifying. 2 and 15, they have nothing in common, so we don't need to simplify. The answer is what it is. Now, mixed numbers are a little trickier, so we're going to do a little bit of notes for mixed numbers. What happens when we have a mixed number? Okay, a mixed number, let's say we have 1 2/3, and we want to multiply that by 2 1/4. Okay, so the first thing we need to do, kind of like step 1, is we need to make our mixed numbers improper fractions. It's easier to multiply these if they are in fraction form. So we're going to make them improper fractions. So all that practice that we did on equivalent fractions, this is one of the reasons why. Let me zoom in just a little bit. There we go. All right, so let's do that first. That's step number 1, make them improper fractions. Let's change the color. So here we go. 1 2/3. 1 times 3 is 3. 1 group of 3 plus 2 is 5. 5/3. And again, we should be getting a little bit faster at doing this now that we've been practicing it for a while. Remember, they are equivalent. All right, do the same thing over here. 2 times 4 is 8, plus 1 is 9. 9/4. Okay, now we can multiply. Numerator times the numerator, denominator times the denominator, just like we did up top here. So I have 5 times 9 over 3 times 4. All right, 5 times 9, 45. 3 times 4 is 12. So the answer is 45 over 12. Well, technically yes, but we do need to do the last step, which we should always do, simplify if needed. If needed. I say if needed because we don't always have to. So like, for example, up here, we didn't need to simplify, but here we should simplify if needed. So let's go ahead and take a look at this. This is an improper fraction. We want to make it a mixed number, which is what we started with. We're basically just putting it back to the form it was when we first started, okay? All right, how many 12s make a 45? Well, 12 times 4 is 48. Can't use that. It's too high. It's too high. So I can do 12 times 3, which is 36. So I know that I can make 3 wholes. That's my whole. Okay, and then what's left over? Well, I just have to subtract 45 minus 36, or I can count up, which is what I would do, and that would be 9. 9/12. Now, 3 and 9/12, 3 and 9/12 can still be simplified. You can leave it as 3 and 9/12. However, 9 and 3 share a common factor, 3. How many 3s make a 9? 3. How many 3s make a 12? 4. So my final answer, fully simplified, is 3 3/4. The hardest part of doing mixed numbers, multiplying mixed numbers, the hardest part of multiplying mixed numbers is converting them from improper fractions and then putting them back into mixed numbers. But that's a very important part of the step, okay? The actual multiplying themselves, you just multiply.